So what is reactivity? It's kind of a confusing thing considering we're just starting to learn about chemistry. But reactivity means how easily an atom has a chemical reaction with another element, and it is all based solely on the valence of that particular atom. And we've talked about valence. We've looked at group numbers on the periodic table and what that tells us about the valence of all the elements in that particular group. So, if an atom's valence shell is not full, that means it's unstable. It will react. And it will do it in one of three ways. It will either share electrons with another atom that does not have a full valence shell. It could give its electrons away to another atom that does not have a full valence shell, or it can take electrons from another atom that does not have a full valence shell. And when they work together, they are trying to achieve a full valence shell, which will remember the first level is 2, and the second and third levels are 8. And for any level after that, it's also 8. So let's look at an example here. We're going to take sodium, which is in group 1. It is an alkali metal, the most reactive elements on the periodic table. The most reactive metals, I should say. So if you draw a Bohr model like we've done in class, you will see that the valence here is 1. Not full, so it is very reactive. We're going to combine it over here with chlorine, which is atomic number 17, and when you build a Bohr model, you end up with 7 electrons in its valence shell, so it's in group 17, and again, it's the most reactive nonmetals. So this one needs to get rid of an electron to become stable, and this one needs to gain 1 electron to become stable. So what happens is electrons can move. So now we end up with our second level completely filled with 8, and our third level on chlorine here completely filled with 8, changes the charges and thus creates a compound. And this is how elements become reactive with one another. Now the other option is that they share electrons, and that's what happens when you create water. Oxygen, here's our Bohr model of oxygen. We have 6 in our valence shell, not full, not stable, wants to react. Hydrogen, with 1 valence electron, again group 1, valence shell is not full, it is not stable, so it wants to react. And so what happens is those atoms slide on over and they will share these electrons. So now we have 2 valence electrons in the first level, which is a full shell. And we have 2 valence electrons here, and then when you add all of these up for oxygen, then that makes a full valence shell.